All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Can you get the door, Jaden, please? Warm-up number 105 is on the screen. That shouldn't take you more than about 4 minutes. From there, get a Cornell note ready. We're going to move on today. How about them apples? Let's go. Let's go. Copy and go. All right, so let's get this show on the road. Tell your neighbor what you got, please, so I can call on some people. What'd you get for your warm-up, please? Should be more automatic by now. All right, let's see. For the first function, f of x equals 2 to the power of x plus 2. What'd you get for f of 2 and f of 3? Jose. One. 32. Hands if you got that. That is correct. Woo. How about for the other function with base 10, power x plus 1? Pass on one. What? Help her out, please, Diego Romo. 1 over 10. For f of 3? Oh, 10 to the 4th, which is 10,000. Hands, have you got that? That is correct. For number 2, just to mention in passing, tell your neighbor what this negative does to the entire function. Flips it, and then we move it 2 to the right and 1 up. Okay. Number 3a, what'd you get for 3a? Frida. 1 over a to the v power. How about 3v, Mr. Q? That's 1. All right, tell your neighbor what you got for 3c, but before you do, look up. Some of you keep skipping this step. This one has an exponent of an invisible 1, then you distribute the power to both. So double check that. This is not just a regular number, this is an exponent. All right, double check your work before we get somebody to give us the answer for that one. All right, Frida, pass someone. Who? Diego Romo. Help him out, Diego Rosas. All right, let's go over this step by step. This becomes 5 to the negative 3 over b to the what, Diego Rosas? To the positive 12. So negative 4 times negative 3 is positive 12, which means this value is not going to move from there. Which is the only one that's going to move? This one. So we end up with 1 on the numerator, 5 to the positive 3 power, times b to the 12th power. So this becomes 1 over 5 to the 3rd power is 125, b to the 12th. Hands if you got that by yourself. Okay, good. All right. Number 4. What'd you get for number 4? Help us out with this one. Jaden. 7 to the x times. Sorry, couldn't hear with the AC. 7 to the negative 2. Very good. Can we have a negative exponent? No. So this is 7 to the x over 7 to the positive 2 power, which can be simplified to 7 to the x over 49. All right. Once again, I'm giving you plenty of practice, guys, because we're about to get into the next functions. We're still working with rationals right now, but this is going to lead us to what's coming up with our pre-calculus stuff. Okay. So right now, what you're doing, I don't know, have you guys seen the Karate Kid when he keeps throwing the jacket to the floor, picking it up, and doing that routine? Well, that's what you're doing right now, picking up the jacket. All right, here we go. Our agenda for today, warm-up number 105, rational functions. Tonight's home plate is 8 problems. Again, oh yes, we got this. So once you're done copying the agenda, turning your home plate from 2 days ago, which was your sign progress or your sign screen shot. And the second home plate was last night. Turn that in as well. That counts as a parte, by the way. Make sure you turn that in. Now, just FYI, BTW, you have till the end of class to turn in last night. The other one, the screenshot, in case you forgot to get your parents to sign it, you have till 3:25 to turn in. However, at the end of this class, at 11:51, Canvas is not going to allow you to turn in the home plate from last night anymore. So if it doesn't upload, just give it to me on your way out. All right? So last night's was that one. Tonight's is this one. Get your phone, take a picture of that. Get a Cornell note, so like that you can get ready for today's session. I'll give you guys some time to turn in your home plate and set up your Cornell notes. Go. All right, here we go. Our objective for today, I can write, solve, and graph rational functions. I can write, solve, and graph rational functions. And like I said, today we're moving on, so make sure you stay focused because it's got a lot of stuff packed in there. All right, here we go. Before we move on, rational functions in your own words. Tell your neighbor what they are, please. What are rational functions in your own words? All right. Caleb, what are they? Very close. Instead of expressions, it should be equations. Yes, equations with fractions. Here they are, equal sign, fractions all over the place. I gave you guys some steps for the graphing, and then we did the writing. So we went to these. We talked about asymptotes. And guess what, guys? We're done with the simple ones, vertical and horizontal. And today we're moving on to the funner ones, diagonal, slant, oblique. Ha, 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 ha. Yes, let's go. So from there we talked about this. We graphed. Now I gave you guys some of these. And what do we do here before we graph? We need to do long division. Is that correct? Because we have an expression on a numerator instead of a 1. We talked about writing them, given a graph. Then we got to these with the squared on the denominator. We also did some of those. We wrote them and graphed them. So just to recap to make sure we know where we're at, write your utensils down, look up to the screen. We are looking at 2 different types of rationals. One that looks like this, g of x equals 3 over x minus 4, and at the end plus 5, or g of x equals 3 over x minus 4, parentheses squared, plus 5. All right? So tell your neighbor where we're going to move the entire functions, both of these, at the end. Where are we going to move those to? All right. Where to, JP? What's that? All right. It's a bella. Where are we going to move this? 4 to the right and 5 up, and that is true for both of them. So what's the only difference from one to the other? The square. Why, Mr. Q? Because the parent function for this one, how do we know the parent function? By looking at the denominator. If it doesn't have a square, so my parent function is f of x equals 1 over x, which means this one is what? F of x equals 1 over x squared. Why do we need to know that? Why did I give you plenty of practice with that? Because we can picture now, by looking at it, how the graph is going to end up. So here's my asymptote, and the graph for this one is here, and then diagonally over here to this side. All right, how about for this one? Same asymptotes, but these start here, and it's going to be side by side with the other. All right, so far so good, yes? Yes, Mr. Q. However, we can't have a 3 on the numerator. Tell your neighbor what to do with that 3 for both of them. What to do with that 3, Christopher? Yeah, he did. Move it to the left and put a 1 on top, so it would be g of x equals 3 as a coefficient, multiplying 1 over x minus 4 plus 5. And the same thing for this one. G of x equals 3 times 1 over x minus 4 squared plus 5. Now, let's understand what this does. Look up, please. What does the 3 do to both functions? Tell your neighbor, please. Yeah, some of you are like, it stretches there, Mr. Q. Okay, but look up to the screen. Specifically with these, here's my asymptote right here, the red one. Look up. All it's going to do is take these away from this asymptote. To what number now? Instead of being at 1, 1, we're going to be at what? 1, 3 for both. Same thing with this one. This one's going to move to what? 1, 3. And this one's going to move to negative 1, negative 3 down here. So basically it's going away from this asymptote. Does that make sense? It's stretching away from it? Yeah? Good recap, yes? Shall we crank it up? Oh yes, copy this please. Example number 4. G of x equals 1 over x squared minus 36 plus 3. Copy that. G of x equals 1 over x squared minus 36 plus 3. Make a blank coordinate plane to the right. Go. Writing utensils down, look up to the screen. Let me go through the entire process of what you're going to do tonight with these kind of examples. So, first things first that you're going to check for, does it have a 1 on the numerator? Yes. Second thing I'm going to check for, what is the parent function? Tell your neighbor for this one, what is the parent function? Yeah, so f of x equals 1 over x squared. You don't need to write it. I'm writing my thoughts over here on the left side, just for me to make a mental note, which means my graph with the asymptotes should be how? Here and on the other side by side. Are we there? So at the end I need to end up with something like that. Okay, so VA x equals, and you're just paying attention, you'll copy right after, HAY equals. Okay. So the easy one to look for right now is a 3. There it is. Okay. However, my VA now has more stuff here. Yesterday we had a trinomial that you can use Power Rangers. Now we can't. So how can I solve for x? Well, set it equal to 0 plus 36. X squared equals 36. Square root x equals, wait a minute, plus minus 6. What? That means we have how many VAs? VAs? 2. A positive 6. Pay attention. Don't copy this yet. You'll copy in a little bit. Just stay focused. And negative 6. All right. My Y is 3. 1, 2, 3. You're just paying attention once again. We'll copy in a little bit. So you're like, what? Now watch. I need to have this kind of graph. Everybody looking? Yes? Which means to the far right of my asymptotes, I need that one. So I'm going to go to my far right, top right, and I need to graph that one. That means that the other one should be at the far what? Far left, top. So that means I'm going to here. However, now we have a space in between. What do we do with that space? Look up. There you go. Copy that, please. You're like, what? Oh, yes. Funner by the minute. Let's go. Copy that. All right, just quick recap. Here we go. We were giving this new kind of function. We checked to see if there was a 1 on the numerator. There it is. So then we started by saying we need to find our VA and our HA. The obvious one was our HA. There it is, 3. But the VA, it wasn't a trinomial. It was a quadratic. We couldn't factor that. So using the Power Rangers. So we use set it equal to 0 and use square roots. There it is. Now I can factor this another way because it's a difference of squares, isn't it? So it would be x minus 6, x plus 6, and then I set that up equal to 0. Solve each equation, and it gives us, yes? And it gives us, yeah, set this as parentheses and so on and so forth. All right. However, what is different about this one? That we have 2 vertical asymptotes here and here, which means it split up our graph by moving them to opposite ends, one to the far right, one to the far left, and in the middle we just created this graph here. From 1 to 5, how comfortable are you up to right there? Okay, 5, 4, 5, 4. Let's do another one together. Here we go. Copy this one, example 4Q. G of x equals 1 over x squared minus 64 minus 5. Get my graph, my blank coordinate plane over here. There it is. All right. So, does it have a 1 on the numerator? Yes. Mental note. Tell your neighbor the parent function for that one. 1 over what? X squared. So mental note, what kind of graph are we going to end up with? The ones that are side by side. Okay. Because it's a quadratic. Okay. I'll give you guys a head start. Go. All right, here we go. So, we need a VA, we need a HA, and of course the HA is right here, so that's negative 5. So our VA, we should have set that equal to 0, plus 64, plus 64, x squared equals 64, square root, x equals plus minus 8. So, 8, negative 8. And our graph should be at the far right where the asymptotes meet, far left where the asymptotes meet, and in between below the red asymptote and between the other two. Hands if you got that. From 1 to 5, how comfortable are you with these? Yeah, 5, 4, 5, 4s, okay. Copy this one. Example 4 super cute. G of x equals 1 over x squared minus 5 plus 1. Now this one's not going to end up with an exact number. You're going to have an approximation. So I'll give you a head start. Copy and all right, check with the neighbors, see what they got so far. Hopefully they have something similar to you. Help them out. All right, let's see. Diego Rosas, what's our HA? Positive 1, so it's right here. All right. Pass someone. Noel, what do we do to find our VA? Equal to 0, so then we add 5. X squared equals to 5, square root, x is approximately plus minus, oh my bad, plus minus, what'd you get, Diego Rosas? 2.20, I'll leave it as 2.2. Hands, have you got that? That is correct, plus minus 2.2. So we got 1, 2, 3, 2.2 is about right there. Negative 1, negative 2, negative 3. Negative 2.2 is about right there. And our graph, the parent function is squared, so that means it should be up here to the top right, top left, and the middle. And have you got that by yourself? Yeah, we got this, okay. However, look up. What if I decided at the end, look up to the screen, what if I decided to do this? Tell your neighbor what that's going to do to the graphs. Talk it over your neighbor. What is that going to do to the graphs? What does that do to the graphs, Frida? Yeah, it's going to move these up to 4 steps away from the red asymptote. So we go 1, 2, 3, 4. And this one as well. How about this one, Frida? Moves it up? No, it moves it away from this one. That means it moves it down 4 steps. Okay. All right, not bad. However, what if I did also, look up, this? So you never what to do from there. Yeah, we flip it. We take this and write it down here somewhere. Same thing with that one. And this one up here. From 1 to 5, how comfortable are you with this so far? Yeah, 5 4s, 5 4s, okay. So I'm not going to give you one more of these because it's the same process where you're going to end up with approximations for the VA. But we got it, yes? Shall we crank it up? Oh, yes. Example number 5, copy that. G of x equals G of x equals x squared plus 5x plus 6 over x plus 1. All right. Let me get my little coordinate plane over here on the side because I'm going to need a lot of space to do a lot of work. A lot of space. All right. So, let's see. G of x equals x squared plus 5x plus 1 over x plus 1. Plus 6 over x plus 1. What is the first thing you guys notice? That the numerator is not 1, is that correct? Okay. So check mark on that. Second thing, can you picture the graph of this one? Tell your neighbor the parent function for this one. Parent function for that one. Everyone? 1 over x. Tell your neighbor how you know, please. Yeah, there's no square on the denominator. Okay, which means my graph, look up, we should end up with a graph that looks like this. 1 on the top left, and 1 on the top right, and then the bottom left, like so. Okay, we good? So, with that said, you're like, wait a minute, so what do I do, Mr. Q? We have an expression on the numerator and a denominator. What do I do? Let's see. Juan, what do you think? Close. Luis, what do I do? Oh, my bad. No Luis. How about Diego Romo? What do you think? All right. Did we ever get some of these that have an expression on the numerator and denominator? We haven't got one that has an expression on the numerator and denominator? Okay, let me repeat that like this. Look up to the screen. Have we gotten some that look like that? Oh my goodness. And what did you do? Long division, my goodness. X squared plus 5x plus 6 divided by x plus 1. All right, so here we go. What number times x gives me x squared? X. X times x, x squared. X times 1 is 1x. Subtract. That means we need to distribute this negative here and here. 5x minus 1x is 4x. Bring down the next term. Next, what number times x gives me 4x? Positive 4. So 4 times x is 4x. 4 times 1 is 4. Subtract. Distribute that one here and here. Cancels. What is 6 minus 4? 2. My remainder. So how do I write this as my answer? How do I write that? X plus 4, what else? Plus 2 over x plus 1. Okay. However, where do I move this to? 2 to the front. So that means that x plus 4 cannot be there. Where do I move the x plus 4 to? To the back. That is correct. And what are we going to replace the 2 with? A 1. That is correct. So we got g of x equals, we move the 2 to the front, replace it with a 1, x plus 1, and at the end we're going to write plus x plus 4. Woo-wee! Getting funner by the minute. All right, so let's start. V A x equals. Tell your neighbor what the VA is. Everyone? -1. Yeah, according to this, yes? So let's go to -1. Get our VA, our vertical asymptote. Go to our HA. Y equals. What did we usually write for our HA? Tell your neighbor, please. A number that goes here, is that correct? But what do we have there now? X plus 4, so we're going to write X plus 4. You're like, what? Yeah, we know how to graph this, don't we? Yes? Yeah, where do we start? At positive 4. 1, 2, 3, 4. And what else do I use to continue graphing? The slope, 1 over 1. 1 up, 1 to the right, 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 or the other way, 1 down, 1 to the left, 1 down, 1 to the left, 1 down, 1 to the left. What do you guys notice about that asymptote? Isn't it slanted? Yes, so from now on, this is known as our slant asymptote. Or in other words, instead of HA, what would we label it now? SA, that is correct, no longer HA. How about the graph? Let's see, look up to the screen. One part of the graph goes at the top right of the asymptotes, is that correct? Yeah, so let's do that over here. Top right of the asymptotes, there it is. The other one is at the bottom left of the asymptotes, yes? So let's go to the bottom left, which is over here. And there you go. Ooh-wee. From 1 to 5, how comfortable with this so far? Yeah? 3, 4, 4, 5s? 5 4s, okay. Let's do another one. Copy this. Example 5Q. G of x equals x squared plus 5x plus 4 over x minus 3. Get a blank coordinate on the right side. I'm going to give you a head start for that one. See how you do. All right. Copy and all right, so we don't have a 1 on a numerator, but we know a parent function. The parent function is 1 over x, which means our graph should look one part on the top right, the other part of the bottom left. Okay, so then we do long division, x squared plus 5x plus 4 divided by x minus 3. We start with x. X times x is x squared. X times negative 3 is negative 3x. Subtract. Distribute this here and here, so we end up with 8x. Bring down the next term, which is 4. That usually is the first mistake some of you do. Some of you wrote 2x. Be careful. Next, continue. What number times x is 8x? Positive 8. Is that correct? So 8 times x is 8x. X times negative 3 is negative 24. Subtract. Distribute. Distribute. So we end up with 28 as remainder. So how do we rewrite this? X plus 8 plus 28 over x minus 3. Can we leave the 28 here? No. Can we leave this one over here? No. So my new function is g of x equals 28 times 1 over x minus 3 plus x plus 8. So my VA or x equals is 3. 1, 2, 3. My my SA is y equals x plus 8. So over here at 8, we go 1 up, 1 to the right, One up, one to the right, one down, one to the left. So my graph should be at the top right and at the bottom left of the asymptotes. Hands, if you got that by yourself. Let's go, let's go. Funner by the minute. Once again, tutoring after school, be there or be elsewhere, yes. And by the way, it's free. All right? I'll stop right there. Or do we have time for one more? No, what? I'll stop right there. Bye.